Hi, this is the second clip for the third week of environmental economics. Today we have to do a number of things, and as I had told you before, many of these things are not in the book and you are responsible for all of them, so I don't want to have to repeat this thing again. I just want to make sure, since this is only the third week, that it is very clear for all of you. Everything that we speak about, whether it's in the book or whether it's in the readings, you are responsible for it totally. That's to say, we are not doing these things only in order to waste time. Having said this, we really have a number of things, so let me see if we can jump right into it. And as you can see, I have been spending some time. I prepared a couple of things in order to save time, and so that it wouldn't be totally freehand. It'll become a little bit easier for you to follow the things that we're going to talk about, especially the ones that are not in the book. Let me take this opportunity to one more time go very quickly over the example of open access. What I decided to do is really to shorten even the table that I gave you last time. So instead of 10 boats, we're going to talk only about 5 boats. It's going to be exactly the same table. The only thing that I want to change is to assume that the cost per boat, instead of $20, is $60. This will make it, at least it will make the solution lie in a smaller number of boats that are going to be required. So we wouldn't need really as long of a table in order to demonstrate that. The second thing that I want to do is to give you a very brief example, numerical example about Coase. The article that you have to read about Coase is a very lengthy article, and I imagine because of the lack of time we're not going to be able to discuss it, and I'll be totally frank with you, there is no need for you to go ahead and read the whole 30 pages. Unless you're an economics major, probably you'll find it to be very boring. But the first 4 or 5 or 6 pages will give you a very clear idea about why is this considered to be such an important revolutionary step that has changed the treatment, the way that we deal with environmentalism all over the world. Let me add, by the way, very quickly, that those who believe in radical environmentalism really are not big fans of Coase, but Coase has become more or less the gold standard for environmental policies all over the world. Then, once we finish that, I want to start dealing with the heart of this chapter, which is really, again, I'm going to work out a numerical example, and we will not be able to do everything, including the proof of sustainability. I will do that in a third session. Okay, so let's just jump into it right now and deal with this example about the open access. Remember one more time, the open access is an excellent example of how is it that one cannot depend on the market to get efficient solutions. So irrespective of what is it that the books have always taught us about how is it that the market always provides us with efficient solutions, we're showing in this case that there are a number of circumstances, and actually some people would like to say that almost every single circumstance is really open to a market failure. We've already spoken about the market failures of externalities, of public goods such as the highways, and right now of the very special case of open access, that's to say the commons that are open to everyone, that are not owned by anyone, and so the idea of managing them becomes extremely difficult. So let me show you right now this. If you look at this, what is it we're going to find out? We're going to find out, as you can see, that if one is going to have one boat then the boat will catch 50 fish. 2 boats, they will catch both of them 90 fish. Let's say the marginal catch of the second boat is 40. The third boat will be 30. The fourth boat 20, and so on. So the first column is that of the total catch. Now, how would we decide what is the efficient solution? Well, let me remind you, especially for those of you that are not economics major, that it really is a very simple matter. Efficiency in all models is going to imply that marginal cost is equal to marginal benefit or marginal revenue, which really means the same thing. Very simply stated, what that means is that if you're going to produce a particular gizmo for $10 and you're going to sell it for $9, then you're not going to go ahead and produce it. So if it's going to add to your cost more than it's going to add to your revenue, that gizmo will not be produced. So the cutoff line will be when the marginal cost is equal to the marginal revenue. The important thing for those of you that are non-economists, and even for the economics major who really have not paid enough attention to this, is that economists do not deal with the totals. They are dealing also always with the marginal. So it's the marginal cost and the marginal benefit and the marginal revenue, etc., etc., of that last unit produced that really counts. So in this case, how would you decide which is going to be the optimum number of boats? It goes without saying the yardstick is going to be that which will produce the greatest profit. So what do we do then? What is profit? It's really nothing else but total revenue minus total cost. So all that you have to do, I mean, even if you're going to just not use any economics, you'll create a table for total cost, and you'll create a column for total cost and a column for total revenue. So if we are to create this column right now in this particular case, what do we find out? Well, the total revenue is going to be nothing else but the first column, the total catch, and we decided that the price per pound, let's assume it's a pound, is going to be $2. So the total revenue that's going to be derived from one boat is 100, from 2 boats is 180, from 3 boats 240, and so on and so forth. Okay, so what's total cost? Well, total cost, we agree that we have a perfectly competitive market. Let's say the price doesn't change. And we're going to assume that the price of bringing one boat fully equipped into the bay to do the fishing is going to be $60. So the first boat, the cost is going to be 60, for 2 boats 120, for 3 boats 180, and so on and so forth. If you subtract right now total cost from total revenue, you'll be able to create the profit. And as you can see, when you look at the total profits, what is it you're going to find out? You're going to find out that they are 40, 60, 60, 40, and then 0. So which is the one that you're going to use? Well, obviously you're going to choose the 60. So let's find out whether that is really what will happen. So this would have been the efficient. Now, how would an economist do it? Remember, as what I said, that an economist wouldn't look at the totals, but will look really at the marginal cost and the marginal revenue. So what is the marginal cost of every boat? The marginal cost of every boat is going to be $60. What is the marginal revenue of every boat? It is that additional revenue due to that particular boat. So you can create these two columns, as you can see, marginal cost and marginal revenue. As you can see, the first boat, its marginal revenue is greater than the marginal cost, so definitely you're going to bring it into the market. The second boat, again, the marginal revenue is greater than the marginal cost, so you're going to bring it into the market. The third one, this is where they break even, so this is the cutoff. So as you can see, the marginal cost is equal to the marginal revenue. Agree with what we have said earlier, that the total profits are going to be maximized at having 3 boats. But if it's an open access, what we are saying, there is no such thing as an ownership of the bay. And so the owners of the boat, of each boat, is going to be owned by a different individual. That's why it's an open access. Then what matters is not marginal revenue, but what matters is average revenue. Because you say to yourself, okay, there are 100 fishermen, and each fisherman, and the average revenue per boat is 100. Or the average revenue per boat is 90, or whatever it is. Then you go by the average and you decide, you make your decision on whether you're going to join or not based on the average. So when you look at the average, as you can see, which is really nothing else but the total revenue divided by the number of boats, you will wind up with this table, or with this column, which is what? 190, 80, 70, and 60. So you find out that for the fifth boat, your average revenue is equal to the marginal cost. So you say to yourself, I'm still going to be covering my cost, and therefore you go ahead and you bring forth that fifth boat. So in an open access, to conclude this very quickly, in an open access we use 5 boats, while if we're going to speak about efficient market solutions, we'll bring 3 boats. The difference is that you no longer are equating marginal revenue and marginal cost. You start equating marginal revenue, average revenue, with marginal cost. And therefore, you will go ahead and abuse or overuse that particular asset. And to remind you one more time of what we've said, I know half a dozen times already, environmental assets, most of them are commons, and that is precisely why is it that they are abused and they are overused. So what do you do right now to correct the situation? Well, there are only 3 things that you can do. You can impose regulations, you can have taxes, or you can privatize the whole asset. You can sell, let's say, the whole bay to one company. Once you do that, then they will operate according to this, to satisfy this. Or you can tax them in order to make the marginal cost higher. They will still be looking at the average revenue, but then the marginal cost will become higher. So if you tax it by 20 or 30 or 40, you will be raising the point of equilibrium all the way, and you decide where is it that you're going to stop. Or you have regulation whereby you say, okay, I'm going to have only 4 boats or 5 boats or 6 boats or whatever it is. So it will require, one more time, government regulation. The market is not capable of solving it in this particular case. I want to demonstrate this, by the way, one more time. The same idea in a graph, and this is very, very powerful. I want all of you to understand this particular diagram. All what I am saying in this diagram is that the number of boats is measured down here. This is over here the dollars. So this is the marginal cost of a boat. So this is the $60. Now the average, the column of the averages will be this. The column of the marginals will be this. So notice right now the powerful thing about this. Whenever marginal cost intersects marginal revenue, this is the 3 boats. When marginal cost intersects average revenue, it will be the 5 boats. And what is the difference? If you're operating at 3 boats, you're selling all of this, and you are getting, your total revenue is going to be the sum of everything under the marginal revenue. So it will be the sum of this plus the sum of this. But what is the cost? The cost is this. Therefore, your total profits are this triangle. This upper triangle is the profits whenever you're going to be operating according to the market at efficiency. if you're going to have open access right now, the area under the marginal revenue, all of these three, will be your total area. But what is your total cost? Your total cost is going to be this. So what have you done? All what you have done, these things are common to both. You're saying that this is going to be an additional loss, and this was the revenue. So really, in an open access, notice what you're doing. You operate until you get rid of all the profits that would have accrued in an open market, in a market situation. In an efficient market, this would have been the profits. Right now, when you operate in an open access, these will be the losses. So the losses will just offset the profits, therefore you will make zero profits over here. So in an open access, there are zero profits. And that is, again, the reason for the overuse and the abuse of the resources. Okay? I hope that this is clearer right now, which would lead me, by the way, to the to this next point that I wanted to discuss, as I told you before. And this point is going to be about Coase. I want to give you only a very simple example about Coase. You still remember what is the Coase theory. Coase is the person who argued that there is no need for government interference or for taxes. That is to say, he was really bolstering the case of mainstream economics of the Smithians. And he thinks, personally, he's always stated that in the interviews, that all what he's done is to go ahead and explain things as Smith would have really explained them, or as he had explained them. So he wanted to just show that the market is capable of getting to the efficient point without any government interference. What are the best cases or the most popular cases of environmentalism, whereby you will have a market failure? The case that was very popular, that was introduced really by Coase himself, will be when you have, let's assume, a particular manufacturing plant that dumps things into the river, but say 4 or 5 miles down away from that particular point, there is a swimming club. So whatever is being dumped into the river by that particular plant is going to affect the attractiveness of that particular beach, of that particular swimming club. The way that we are suggesting that will be solved, since there is no market, is for somebody to pass regulations or to pass taxes in order to satisfy both of them. What Coase is saying is that there is no need for any government or for any regulations. And I'm going to show you right now another very popular example, a very quick example. And if you understand this, you really understand all of Coase, because it is one of the simplest ideas. It isn't complicated at all. All what Coase was trying to say is, if it so happens that you have two parties and they have perfectly well-defined property rights, and it makes no difference who has the property right. This is really one of the controversial things about Coase also. That's to say, whether the polluter has the right to pollute or whether society has the right to have a clean environment, it makes no difference. You come to the same solution. But we find it objectionable when the polluter has the right to pollute. And that's, by the way, why in the United States we've adopted the law that says that the polluter pays. So whenever there is a particular problem, it is the polluter that is responsible for it. So when water in the Hudson became full of PCBs, who is it that we went to in order to clean up the Hudson? We went to GE. Although when GE was dumping its PCBs into the Hudson, it wasn't illegal. But yet, since the issue of damaging the environment occurred as a result of that particular dumping, then GE was held responsible for it. But notice what we're really saying. We're saying that according to the pure theory, it makes no difference who is it that has the right. They will both lead to the same solution. In one case, which we find a little bit not palatable, is when we have to pay the polluter to stop polluting. And that's why we passed a law that the polluter always pays. So the very simple example that I want to share with you right now is the following one. Let me make it, put it here, see if you can follow it here. Yeah, okay. I will move it this way. Yeah, okay. So all what we have right now is that we have an office space that is occupied by either a smoker or a non-smoker. It makes no difference. And then we hire another person to share the same office. So one of them is a smoker, one of them is a non-smoker. There was a smoker and we hire a non-smoker, we have a non-smoker, we hire a smoker. It really makes no difference. What Coase is saying is that these two individuals will be able by themselves and of themselves to work out an agreement whereby they will get to the point that satisfies both of them and that maximizes their satisfaction without the need of passing a regulation of imposing or if imposing a tax. Let's see how is it that it will work. Well, the smoker, in order to cut down on the first cigarette, it's not very difficult. Let's assume that the guy smokes 20 cigarettes a day. So if you ask him to cut down on only one cigarette, he says, okay, you've got to pay me $4. So it's worth $4 to him. The non-smoker, to cut down on one cigarette, to him, I mean, that is really very important because he despises smoke. And so he's willing to pay $12. Is there a room for a deal? Yes. You demand 4 not to smoke. It means 12 to you in order to have the other party cut on smoking. So they'll work out a deal. What about the second cigarette? Now, the smoker, the second cigarette is going to become more difficult than the first cigarette. So he's going to demand right now $6. The non-smoker, the air has already been cleaned a little bit, so the second cigarette, cutting down the second cigarette, is not going to add as much to him. Therefore, he's going to require a little bit less. But in this particular case that I've just worked out, is that let's assume the smoker demands 6, the non-smoker is willing to pay 9. So again, they have a room to go ahead and arrive at a deal. We go right now to the third cigarette. Now, it has become a little bit more difficult for the smoker to quit smoking, and so he demands $7 to cut down 3 cigarettes. The air right now has become cleaner, and so it doesn't mean as much to the non-smoker, and the non-smoker is willing to pay 7. Now, both of them over here, it means the same amount, that cigarette. So they will agree, therefore, on cutting 3 cigarettes. They will cut a deal in between them, whereby one of them, the smoker, will cut down on 3 cigarettes, and the non-smoker will pay the smoker for not smoking. If you go to the fourth, as you can see, just to show you what will happen, the fourth right now has become so difficult for the smoker to cut down, and so he demands 10. while the air has become so clean relative to the non-smoker that the last cigarette means only $5, so they will never be able to work out a deal. So they will work out a deal, but how would they do it? Only if there is no cost to the transaction, and only if we have well-defined, and these words are very important, well-defined property rights. One of them has the right either to smoke or to have clean cigarettes, clean air, and not to smoke. Excuse me for a second. So in this case, as you can see, the shortcoming of Coase is that it wouldn't work out if you have a very large number of people, because then you will have a cost to the transaction, and it wouldn't work out because unless you have a well-defined property rights. But the point is that there will be no need for regulation, and so you restore the idea of having an open, of having a free market that does not require a government interference. And if you buy this, I have a bridge for sale. It's a very good idea, and we've really instituted certain things similar to it, as I said, when it comes to dealing with emissions by creating a market, by defining property rights, by creating artificial markets that sells options, the right, you buy the right to use, the right to go ahead and pollute, or you buy the right to take that particular option and take it away from the market. But in both cases, you would have defined property rights, and you will have attempted to get a solution that does not require any regulation. Now, having dealt with this, we're going to have right now deal with something a little bit more complicated, in the sense that I want you to be able to solve all of these problems exactly according to what we're going to talk about right now. So the next step, therefore, having dealt with this, is that we're going to show right now, we've shown already, we spoke last time, about static efficiency. That's to say, static efficiency, if you have a supply and demand, it is the most efficient allocation of the resources. It satisfies the criteria of efficiency, and we have absolutely no problem with it, except for the fact that it's not realistic. If you can go ahead and make it realistic, then yes, it is fine. So we want to find out right now, what about dynamic efficiency? That's to say, what about efficiency during two different periods of time? When we do that, it becomes a little bit more difficult or a little bit more problematic. Why? Because we're going to be talking right now about at least a very important role of the interest rate. Because when it comes to time, then the interest rate becomes important. But before we get to that, let me start right from the beginning by working out a very small example with you that rests only on the supply and demand curve. I am going to show you right now, and I worked out a problem about how is it that if we are to go ahead and apply a very small definition of the market, we're going to be able to work out in detail how is it that efficiency is going to be worked out, and how is it that we're going to do the allocation. First, we have to review some of the basics. So let me look at the basics, which really are on the left-hand corner. So we're going to say that P is equal to 10 minus 0.2Q. Now, I know that we're not in a classroom, so I'm going to ask the question, but I'm not going to get an answer. So what is P is equal to 10 minus 0.2Q? I hope all of you know that this really is a demand curve. Because a demand curve is nothing else but quantity is a function of the price. Now, this is exactly the same as saying 0.2Q is equal to 10 minus P. But it is very common for these models that we're going to be working to express the demand curve in terms of price. So if we express it in terms of price, it is P is equal to 10 minus 0.2Q, which is the same, as I said, as saying 0.2Q is equal to 10 minus P. Therefore, Q is equal to 50 minus 5P. Now, the only other assumption that we're going to make, which is going to be very helpful for all of you, I hope, especially if you remember some of the basics of your economics, we're going to say that marginal cost is equal to 4, and it's constant. It's very important, by the way, that we're talking about constant marginal cost. So the marginal cost does not increase like a J, but is going to be constant. Again, in order to simplify the diagram. So what does that mean? That means really that the marginal cost is the supply curve in essence. So you have right now a demand curve and you have a supply curve. Where a demand curve intersects the supply curve, this is going to be your equilibrium, right? So what do you do in this case? Plug in the 4 for the price. If you plug in the 4 for the price, you'll find out that the quantity is going to be 30. When the quantity is 0, by the way, how much is price? 10. So when the quantity is 0, the price is 10. When the price is 0, the quantity is 50. So this is the demand curve. This is the marginal cost, so it is 4 and 30. Now, let us assume, for the sake of the argument, that total supply in this particular case, I'm going to assume is 40. And that we have to find out what is the optimum allocation. How is it that we're going to allocate this 40 over 2 periods, 2 years? Say one of them is 2015 and the other one was 2016. How do we allocate this 40? Do we allocate it 30-10, 20-20, 25-5, 5-30, 5-25, or whatever? There are an infinite number of allocations of allocating this 40 between the two. Now, the task is relatively simple. What we have to do, we have to find out what is the allocation that maximizes present value of the net benefit. The net benefit is really nothing else but what we spoke about last time, which is going to be the consumer surplus. If this is the supply curve, then this is the consumer surplus. There is no producer surplus in this particular case, because we're selling things at the marginal cost. And the marginal cost is constant all throughout. So we have to find out that allocation that maximizes the net benefits. Now let's find out how is it that we're going to do it. Well, let me assume, for the sake of the argument, that I have 40 and I want to give 30 to the first period, 2015, and I'm going to give the 10 to 2016 to the second period. What's going to be my maximum present value net benefit? In this case, as you can see, which is nothing else but a duplication of the previous diagram, I'm saying right now that when the marginal cost is 4, I'm going to be using 30. So how much is the surplus? The surplus is the area of this triangle, right? That's to say we would have been willing to pay all of this, let's just say the benefit to society, is the area under the demand curve. But we pay for it, this area, the cost, therefore the surplus is this. So what is, if I don't show you this, if I cover it for a minute, what is the area of this triangle? It is the base times the height over 2. So it's going to be 30 times 6 over 2, which will be 90. So 90 is the area of the surplus during period 1. What about period 2? Well, period 2, as you can see, we're going to have 10 only left. So the first thing that we've got to do is to calculate what would be the price. We're assuming that the same demand curve, by the way, is true for both periods. Again, for simplicity's sake. So if it's the same demand, I take this 10, I plug it into the demand curve that P is equal to 10 minus 0.2Q. So 10 times 0.2 is 2, 10 minus 2 is 8, therefore the price is 8. So what is the area of my net benefit in this case? The area of my net benefit is going to be the sum of these two areas, right? It's going to be the sum of this triangle plus the sum of this. What are these two areas? Well, this one is very easy, very straightforward. It's going to be 10 times 4, because the difference between 8 and 4 is 4, so it is 10 times 4, which is going to be 40. What about the area of this? Well, again, it's going to be the base times the height over 2. So it's going to be 10 times 2 over 2, which is going to be 10. Therefore, the total benefit over here is going to be 50. But this, notice, is going to be next year. It's going to be the second period. So it's not the present value. Now, this is what is very important about one thing that we're going to be using quite a lot for the remainder of the semester, the role of the interest rate. We're going right now to find the present value, which means that we're going to discount that 50 to find out what is the present value right now. 50 is going to be the value next year, but what is the value this year? Well, we use the very simple formula. I hope all of you are familiar with it. If it so happens that you have $100 at a savings bank and the interest rate is 10%, how much are you going to get next year? Well, you will have next year 110. Why? Because you say that future value is equal to present value multiplied by 1 plus the interest rate. If it's more than one period, you raise it to the power n. So the present value, therefore, is nothing else but the future value divided over 1 plus I for only one period. And right now we're dealing only with only one period. So the present value is going to be 50 over 1.1 if the interest rate, we're going to assume that the interest rate is 10. So 1 plus 0.1 is 1.1. So 50 over 1.1 will be 45.45. So the total net benefit of this allocation was the 90 plus the 45.45. It will be 135.45. Now notice one more time what is it that we're saying. We're saying, okay, this is only one allocation. What if I don't want to allocate them 30-10? What if I want to allocate them to be 10, let's assume 25-15, or maybe 20-20, or I know 18-22, and what have you. I'll have to work this for every single possible allocation, and then compare the total benefits to find out which one gives me the highest benefit, because each one is going to give me a completely different benefit. Now, how are you going to do that? I mean, that's going to be next to impossible. Obviously, if you have a computer, the computer can probably do it for you very quickly by trying to move from one to the other to find out which is the one that's going to give you the highest present value. But if we don't have computers, we'll have to learn right now how to do it. And for 2 periods, and this is the most important part of this chapter, and in a sense maybe the more difficult part of this particular chapter, is going to be how to do this initial allocation. Now, this initial allocation can be achieved rather quickly if we follow this particular diagram that is used quite often by economists. This is something that many of you might not have seen before, but it is a staple of economic theory. It's a tool. And what this tool is going to be showing, as you'll see in a minute, is going to be showing a diagram which will not be very difficult to follow because it is in your textbook. But what this diagram is showing really, it's taking the first period, so the period that has a demand curve. So this is the price and this is the quantity. Now you take also the second period, which has exactly the same thing, a demand curve and the price and the quantity, but you flip it over. Now by flipping it over, this will become the second period. So you take this for the second period and you flip it over, you will get such a diagram. You will have therefore this demand curve for period 1 and this demand curve for period 2. Now, one very important crucial thing to note is that I am not going to take all the demand curve and flip it over. I'm going to take only the portion that is above the marginal cost. And what was the marginal cost? The marginal cost was 4. What was the highest price? It was 10. So the highest price in this case is going to be the 10 minus 4 is going to be 6. That is to say, we're going to be taking this particular diagram and we're going to be flipping only this part. So this is going to be this part and the other one will be the second one, which will be flipped over. So we will be over here measuring, as you can see, 0, 1, 2, 3, 4, 5, up to 40, since we are dealing with 40. And for the second one, we will be starting from here, 0, 1, 2, 3, 4, up to 40. And therefore, if you add both of these, they will always add to 40. Now, all what we're saying mathematically is that if one can solve this particular diagram, then one gets the optimum allocation for a 2-period model. So what does this represent? This is the demand curve. What is this demand curve? As we all know, it is 6 minus 0.2 Q sub 1, right? That was the original demand curve. But right now, I'm no longer going to say 10, I'm going to say 6. So really, it's 10 minus the marginal cost. That's to say the 10 minus the 4. So it's 6 minus 0.2 Q sub 1. What about the second one? Well, the second demand curve is really the first demand curve, which is 6 minus 0.2 Q sub 2, though. And all of that is going to be discounted, and we're going to assume that the discount rate 1.1. Now, I want you to follow this as carefully as possible because you will be held responsible and you've got to be able to work it out. Let's say if somebody gives you a demand curve and asks you to do and gives you the fixed supply and asks you to go ahead and allocate it between 2 periods, you should be able to work out that optimal, efficient allocation, because this is the one that maximizes the present value of the net benefit. So how would you solve this mathematically? Well, you have an equation for this, you have an equation for this, you set them equal to each other, which will give you this. And that's exactly what you're looking for, right? But notice right now, how is it that you work through it? So it is 6 minus 0.2 q sub 1 is equal to 6 minus 0.2 q sub 2, all of this discounted by 1.1. If the interest rate is 10%. If the interest rate was 5%, it would be 1.05. If the interest rate was 20%, it would be 1.02. Now, can you solve this one equation? So the whole model is one equation, but I have two unknowns. Is it possible to solve one equation with two unknowns? And the answer obviously is no. So one more time, I need to apply a small, let's call it a trick. I've got to make a slight transformation. What do I have to do? I've got to express one of the variables in terms of the other. Can I do it in this case? And the answer is yes, because I knew from the beginning that both quantities must add up to 40. Because that's what I'm doing. I am allocating the 40 between these two periods. So q sub 1 plus q sub 2 is equal to 40. If that is true, then what I'm saying is that q sub 1 is equal to 40 minus q sub 2. Or if you wish to do the reverse, you can say q sub 2 is equal to 40 minus q sub 1. Now, all what you have to do is to go ahead and solve this particular equation right now. So it is going to be 6 minus 0.2 into, instead of q sub 1, you put right now 40 minus q sub 2. So 6 minus 0.2 all into 40 minus q sub 2, which is equal to 6 minus 0.2 q sub 2 over 1.1. From here on, it should be simple. But if you've never done it, this is where people go wrong. I am going to skip a couple of steps. But all what you have to do is really cross multiply. So multiply this by the 1.1. So what you get over here is that you're going to get 0.42 q sub 2 is equal to 8.2. What you do over here is you expand this, then multiply all of it times 1.1, and put all the q sub 2 on one side, and obviously the numbers on the other side, and so you get 0.42 q sub 2 is equal to 8.2. So how much is q sub 2? It is 8.2 over 0.42, which is 19.524. Now, if q sub 2 is 19.524, how much is q sub 1? Q sub 1 is going to be, remember, both of them add up to 40. It's going to be 40 minus this. So 40 minus the 19.524 is equal to 20.476. So right now, I have taken that 40 and I've allocated it over these two periods. One period, the current period, gets 20.476, the second period gets 19.524. And then I can take both of these quantities, plug them into the initial demand curve in order to find out the prices. So I find out that the price during the first period is going to be 5.925, and in the second period is going to be 6.096. So I have right now both the price and I have what else? I have the quantity demanded of this particular allocation. The next step, which I will do later on, because I'm gonna just put it one more time over here just in order to save time on the board so that we'll be able to go through it rather rapidly. But let me give you an idea from right now so that you'll know what to anticipate. We have this allocation, and obviously according to our theory, this is the efficient allocation. We know it's efficient. The issue is, from an environmental perspective, is it sustainable? What is sustainability, if you still recall? We don't want the present to grow at the expense of the future. So the most important criteria is that you don't want the present value, the net benefit of the first period to be greater than the net benefit of the second period, because that will not be sustainable. And that's what we're going to find out later on. We're going to find out that according to this, an efficient allocation violates the conditions of sustainability. So we cannot speak of a market, of an efficient allocation, and yet of sustainability, unless we go ahead and interfere. And that is going to require, as you will find out, some more computations very similar to this one, but you'll have to again be able to work through all of these particular manipulations. So notice over here one more time what we have said. If this is right now discounted by 1.1, what if I were to discount it by 20% of 10%? What is going to happen? This will become the demand curve. If I'm going to discount it by 30%, it will become this, 40%, and so on and so forth. So the greater the interest rate, this is going to shift this way, right? It's going to swing this way. If it swings this way, what's going to happen to the allocation? Now this is very important, and we're not going to repeat it very often. What will happen, as you have noticed, is that the share of period 1 increases. So the higher is the interest rate, the greater is the share of the present. And that, I hope, as all of you have already concluded, is the single most important reason why environmentalists refuse to use any discount rate. They refuse to use an interest rate, because an interest rate is always favoring the present, and the higher it is, the greater is that particular favoring of the present. The lower it is, if there is no discount rate, by the way, then this will be identical to this, and then what will be the allocation? It will be 20/20. Right? So it's very important to note that in order to have a problem for allocation, by the way, the first thing that you must have is that the quantity supplied must be less than the demand in both periods, the market demand in both periods. Remember, we said that the market demand in each period is going to be 30. So if the quantity supplied, if we know that we have 70, then we have no problem. There is no problem of allocation, because period 1 will get 30, period 2 will get 30, and we have 70. The problem of allocation arises only when we have less than 60. That's when you have to worry about how to allocate that particular fixed resource. And we're using 2 periods only for simplicity. Later on in the semester, we will use a multi-period analysis, which will become a little bit more realistic. But as you can see, the principle is really essentially the same. But the important thing to take out of this is that there is a way of finding out the efficient allocation by setting the demand curves equal to each other, but by taking the second demand curve and discounting it, that's to say, and that will be the second demand curve. And then the rate of interest is always going to favor the present, and it did in this case. Notice that the present got 20.476, while the second period got 19.524. But what happens to the price? The price of the second period is higher than the price in the first period. Why? Because of scarcity. Since we used more in the first period, in the second period is going to be higher. And that is the notion that we speak about as being the marginal user cost or rent. That is the difference between the marginal cost and the price. So the price in period 1 was 5.905. Marginal cost was 4, so how much was rent? It was the difference between them. So it would be 5.905 minus 4, which will be 1.905. But during the second period, the price was 6.096. So you take the 6.096, subtract from it the 4, the marginal cost, and you'll find out that the rent or the marginal user cost is 2.096, which is higher than rent during the first period. By how much higher, however, and I'll leave it here, it is higher by 10%. Why? Because the interest rate is 10%. So notice the important role of the interest rate. It determines the allocation, and it determines the prices and the price increase, at least the price increase due to the rent portion. So we'll take a short break right now, and I'll come back after I put on the board the new ones, because I don't want to do them freehand. I want them to be a little bit clearer and more precise.